quite simple. And we want to find the median, mean, okay? And mode is obviously, this is going to be, all three of these are going to be mode or no mode. Mode means that it occurs most often. I'm going to show you how to find all of these in your graphic calculator. So let's start with the median. So what you're going to do is you're going to go to math, okay, and then you're going to go down to statistics, and then you're going to go to median. Let's find the median first. And then there's braces above the parentheses. So second parentheses, braces. Then you're going to type in 4, comma, 2, comma, 9. And then you're going to close your braces. Okay, that's above the right parentheses. And close your parentheses, hit enter. And the median is 4. Well, that makes sense. If you were to put this in the order, you're going to go 2, 4, and 9. So there's your median, it's 4. Well, how do you find the mean? You do the same thing, okay? And you can cut corners here, so I'm going to cut corners here. We'll go, let me go. So, alright, let me just clear that. Okay, let's say I want to find mean. So, math, statistics. Okay, go down until you see mean, hit enter. Then open the braces. That's the left braces, above left parentheses. And type in 4, comma, 2, comma, 9. Close the braces, and then close the parentheses. Okay. Now, hit enter. Oops. Too many braces, huh? Parentheses. Okay, hit enter, and there it is. The mean is 5. So all it did was it added 2 plus 4 plus 9 and divided by 3, and that gave us 5. Okay, how do you find the variance, and what is the variance? Okay, well, let's find the variance first, and then I'll show you what the variance is. So what I'm going to do is I'm going to move my arrow. Let me take a shortcut here. Clear that. And then I'm going to put in second math, go down to statistics, go down until you see variance, hit enter. Okay, and everything else typed in, so I have to retype it. So hit enter, 13. So the variance is 13. Well, how do they find the variance? Well, we found out the mean to be 5. Okay, well, how far is the 9 from? Well, that's 4 units. And how far is the 4 from? And that's 1 unit. And how far is the 2 from? That's 3 units. So the difference between the mean and 2, difference between mean and 4, difference between mean and 9, you take those and you square each one of these. Okay? And then when you square that, it's going to give you 16. When you square that, it's going to give you 1. And when you square that, it's going to give you 9. And you're going to add them together, and it's going to give you 26. Okay? The sum of the squares is going to give you 26. Now you divide by 1 less than the number of numbers you had. So you had 3, so therefore you divide that by 2, and that's going to give you 13, and that is your variance. That's how they got the variance. Okay, now variance is related to standard deviation, so let me show you how to find standard deviation. So if you're given a set of numbers, you want to find standard deviation. I'm going to clear this. I'm going to take a shortcut again. I'm going to clear this off, variance, and then I'm going to go to second math. I'm going to go down to statistics, and then this time I'm going to go down to standard deviation. Hit enter. Okay, then I'm going to hit enter. Okay, what standard deviation is? Standard deviation, okay, is 3.605, or square root of 13, or square root of the variance, and that's what standard deviation is. Okay. Now, that's how you find mean, median, okay, variance, and standard deviation. That's all you do. Type in the numbers. Okay. Okay, so if you get a question like that, just type it in. So let me go to parametric equations. Okay, first of all, you want to change the mode. You want to go to the mode in the calculator, and then where it says function, you want to hit enter. Come on, mode. Okay, go to the right. Right now you're probably at the function, and you don't want to be at the function. You want to go to parametric. So go down, hit parametric, highlight that, hit enter, and then hit enter again. It will save it, otherwise it won't save it. Okay, now I'm going to go to y is equal to. Okay, I already typed in. So let me typed in something. I want to clear that. So let's say we have a parametric equation. Let's say x is equal to 3t minus 4, and y is equal to 6t plus 2. Okay, so those are parametric equations. And now a parameter here happens to be t. Okay, and t stands for time. Okay, this is the position of a particle in y direction with respect to time. This is the position of the particle in the x direction with respect to time. And t is our parameter. So when we're expressing everything in 3 dimensions, where we have x as one variable, y as the variable, and t is the parameter, of course, technically, if you want to express a real world problem, it's going to have a z component, and that might be, let's say, 2t plus 1. Okay, but we're not going to do that right now. So, but this does tell us what the position is in terms of x, y, and z with respect to time. Okay, so we're going to in SAT 2, they'll just stay with x and y. Now, one thing they'll ask you is get rid of the parameter and express it in x and y. That's easy. You just solve. You go to the x and solve for t. So you're going to go x plus 4 over 3 is my t. And then you take that and you substitute into the y. So y is equal to 6 times x plus 4, all that over 3 plus 2. Okay, and that is y is equal to, we can reduce that to 2. So 2x plus 8 plus 2, which is y is equal to 2x plus 10. And that's an equation of a line. Okay, so how do you graph that? When you put them in parametric mode, okay, this is also known as vectors. Okay, so this is known as a vector, and this is also a vector. Now, you just type in parametric mode. So let's type in 3 times t. T is right there. Okay, minus 4. Hit enter. And then the second one is 6 times t plus 2. Hit enter. Okay, now we have our two x, x and y plugged in. You can go even more if you want, but you don't have to. And then all we're going to do is we're going to zoom, and we're just going to go standard to the graph. And there it is. If you want to zoom out, let's zoom out a little bit. Okay, enter. Okay, so the line looks like that. Alright? Alright. So, sometimes what they'll do is they'll give you these two, and they'll ask you to match up with the graph, or they'll give you these two, and they'll ask you to match up with the equation, okay, in a rectangular form versus parametric form. Okay. Let's go to, and the reason it stops here, it doesn't go on forever, is because of our t. Okay, and t is 0. T is 0, time is 0, this is 2, and time is 0, so negative 4, okay, and that's why it stops there. Okay, so zoom in a little bit, zoom in, okay, and as you can see, it's stopping, and that's why it stops. Because time can never be negative, t can never be negative. Alright, now, in a rectangular format, okay, this is the same equation as this, the only thing is it has a domain restriction. We can also, let's do one that is not a line. Here's another example. Let's say y is equal to square root of t, or x is equal to square root of t. Okay. And then let's say y is equal to 2t plus 4. Y is equal to 2t plus 4. Right. And let's say they want you to match up with an equation. Okay. In rectangular form, so all we're going to do is we're going to solve for t. So that was going to give me x squared is equal to t. We're going to take that and substitute that in there, which is going to give you y is equal to 2x squared plus 4. That looks like a parabola. And if we were to graph these in a parametric form, okay, we should get a parabola. So let's go graph it in parametric form. Go here, okay, there, and then type in rad t. So rad t for the first equation, and then the second equation is 2 times t plus 4, and let's tell it to graph. Okay, again, the reason the parabola does not continue on is because our limitations with the t, okay, the least t is going to be 0, and that limits our x and y value. Okay, the y value is going to be 4 maximum, and x value is going to be 0. Okay, because t cannot be anything less than that. Right. So we could get even fancy if you want, and those things are given to you on page 95. So if you want to keep playing with more of these and use trig functions, you probably won't see trig functions on the SAT2, but you might want to play with it. It's on page 95 and 3 through 12. 3 through 12 on page 95 deals with parametric equations. And of course, if you want to convert to trig functions from a parametric form to a rectangular form, you have to use cosine squared x plus sine squared x is equal to 1. And you also have to, sometimes you have to use a trigonometry for tangent squared x also. Okay, but most of the time it's that. Alright, but I wouldn't really worry about that. So let's go to polar coordinates. As long as you can change from parametric to rectangular for the basic equations, you should be good to go. If you want to ask anything more complicated, as long as you can match up with the graph, you have a graphing calculator so you can match it up, then you're good to go there also. Alright, so the other thing is polar coordinates. Okay, what are polar coordinates? Well, polar coordinates are given, first one, let's say you're given a number, and that's 2, and let's say you're given pi over 6, and they ask you to plot this point. Well, basically, the first one is the radius, and the second one is the angle. So you go to pi 6 is that line right there, and you'll go 1, 2 units, that's 1, 2, 3, 4, so pi 6, this is my pi 6, and that's my 2, and this point is 2 comma pi 6. Okay, well, let's say if they want you to plot negative 2 comma pi 6. Okay, to plot that, you go to pi 6, okay, and this is the same line right here, but instead of going to the right, you're going to go to the left 2 units, and that point is the negative 2 comma pi 6. Okay, and let's do one more. Let's say I want to go to 3 comma negative pi 6. Okay, how do you plot that? Negative pi 6 is this line right here. Okay, that's my negative pi 6. Okay, because I'm going down. And 1, 2, 3, 4. 1, 2, 3, 4. 3 comma negative pi 6 is here. That's the point right there, because you go, if this is positive, you go towards the same direction as the angle. Okay, and if this was negative, let's say you have a negative 3 comma negative pi 6, then you go away from the angle, you will end up here. And that is the negative 3 comma negative pi 6. Okay, it's a positive. R is positive, you go towards the angle. R is negative, you go away from the angle. Alright, that's how you plot polar coordinates. Now, most of the time what they will do is they will give you a polar coordinate and then they'll ask you to convert it to a rectangular form. So let's take an example. And let's say they give us 6 comma 2 pi thirds. Okay, 2 pi thirds. So 2 pi thirds is my angle, this is my radius, and this is my angle. Okay, and I want to see where that is. We know what that is in polar coordinates. We just went over there. Let's go ahead and do that just for the heck of it. 2 pi thirds. Okay, it's going to be here. That's my 2 pi thirds line. And then 6, let's go over here, call that 6. Okay, that's going to be like that. Okay, that's the point, but we want to express that point in rectangular form. So to do that, what you have to do is you have to use some of your old knowledge that, if you remember, x is equal to, or let's go this way, cosine of some angle is equal to x over the radius r, and then sine of some angle on the unit circle is y over the radius r. It just saw the unit circle, r happens to be 1. Okay, so my x is equal to r times cosine of theta, and here I get my y is equal to r times sine of theta. Alright, they give us an r which is 6, and they give us an angle which is 2 pi thirds, so times cosine of 2 pi thirds. Okay, and that is equal to 6 times, and what is cosine of 2 pi thirds? Well, cosine of 2 pi thirds happens to be negative 1/2. So that will give us negative 3. And then here, you're going to get y is equal to 6 times sine of 2 pi thirds, because that's my angle. So y is equal to 6 times, what's sine of 2 pi thirds? That's rad 3 over 2. So that reduces to 3. So that's 3 rad 3. So my point is negative 3 comma 3 rad 3. And that's what this point here is. This point in polar coordinates is that, but in rectangular coordinates that's negative 3 comma 3 rad 3. That's how you convert from polar to rectangular. Now let's go backwards. Okay, let's convert from rectangular to polar coordinate. Okay, let's do an example. And let's say we're given negative 2 comma 2 rad 3. Okay, and that is my x and the y. And I have to convert this into that's my x, that's my y. I'm going to convert this into polar coordinates in terms of r and theta. Well, first of all, let's take care of the r. Well, we know we're talking about polar coordinates, we're talking about a circle. It's going around a pole. Okay? That's why it's called polar coordinates, going around a circle, this pole right there. So we know x squared plus y squared is equal to r squared is the formula for a circle. So we're just going to plug in the information we have, which is negative 2 quantity squared plus 2 rad 3 quantity squared is equal to r squared. And we're going to solve for r. So this becomes 4 plus this becomes 4 times 3, which is 12. Okay, which is equal to r squared, and that's 16, so r is equal to 4. So we found 1, r is equal to 4. Now the only thing that's left is to find theta. Well, this is x and y, okay, but we also know from trig tangent of theta is equal to opposite, which is y, over adjacent, which is x, sine over cosine. So we're going to plug in what we know, which is 2 rad 3, all that over negative 2. And we're going to reduce that, and that is going to give you negative rad 3. So tangent of theta is equal to negative rad 3. So we have to figure out where the tangent of theta is equal to negative rad 3. Okay. So on the unit circle, okay, obviously it's got to be either in this quadrant here, okay, or this quadrant right there. Okay. So, and it could happen over and over. So let's go find that point right there, and that point turns out to be where, if you don't know how to do that, you can use a calculator, and that's going to be 2 pi over 3. Okay, so this is 2 pi over 3. Now we only found one point right there, so if we want to find multiple points, okay, so then we would write that as a 4 comma, okay, 2 pi over 3, okay, plus or minus, okay, 2 n pi. We can write it like that, okay, plus, excuse me, it's plus, because we're going the same direction. Because otherwise, if we go minus, then we're going to go down. Or you can write this as a negative 4, comma, 2 pi over 3, or, no, this would be 5 pi over 3. That's 5 pi over 3. So 5 pi over 3 plus 2n pi. Okay, you can write it like that. But most of the time they just want you to convert from rectangular to polar. You just want one point, and you can use that. Now if you want some more practice problems for this, you can find this in your calculus book, all these calculus book, the last section and this section. If you haven't turned in the calculus book, that is. Okay, and page, these are polar coordinates. So page 734, and you can go 3, 4, and 5. Okay, problems 3, 4, and 5. That's it. You won't see much more than that in polar coordinates, and you'll get more in depth with polar coordinates in BC calculus, but that's all they. If it shows up at all, that's all you will see. Okay. All right. I'm done. Good luck.